Alright, welcome geometry. Now, yesterday we learned all these awesome things about parallel lines. Alright, we learned that if you have parallel lines, all these things are true. Corresponding angles are congruent. Alternate interior angles are congruent. Alternate exterior angles are congruent. Same side interior angles are supplementary, and same side exterior angles are supplementary. So we learned all these things, and we said if parallel lines, then all this stuff is true. Now today we're going to stick with the same idea. It's just we're going to flip the language on you a little bit. So proving lines parallel with the converse theorem. And before we get started with the math here, I want to drop a little knowledge on you about this word converse. Now, the word converse is, in mathematics, sometimes we have to change the nature or the order of the sentence to look at the truth value. So let's say we have a sentence that says, if your name is Mr. Pagan, then you are the coolest person in the world. Coolest. Okay? So if Mr. Pagan, then the coolest person in the world. Okay, now, if we're talking about the converse of the statement, I would flip the main ideas. So I would say, if you're the coolest person in the world, then your name is Mr. Pagan. So if you notice, I've taken the main idea of the end sentence and brought it up front, and vice versa, the main idea of the front and brought it to the end. So I just flipped the structure of the sentence. So if you are Mr. Pagan, then you are the coolest person in the world, and then I flipped it. If you are the coolest person in the world, then you are Mr. Pagan. So that's kind of a little lesson about the converse in the English language. So now let's focus on the converse in terms of our geometry and our math. So yesterday we said if parallel lines, all these things are true. So today I'm going to say if these things are true, then we know we have parallel lines. So we just kind of have to flip our brain and start thinking backwards. So if corresponding angles are congruent, then we know the lines are parallel. All right, you see that? So yesterday it was if the lines are parallel, then corresponding angles. Now we're saying if we know this, so if we know the corresponding angles are congruent, now I can determine that my lines are parallel. Alright, so the same goes for all our other angle pairs. If alternate interior angles are congruent, then the lines are parallel. If our same side interior angles are supplementary, then the lines are parallel. Alright, so if we know that this is 80 and this is 100, I know my same side interiors are supplementary, therefore I can conclude that my other two lines not on the transversal are parallel. Alright? And then the next one, if alternate exterior angles are congruent, then the lines are parallel, and if same side exterior angles are supplementary, then the lines are parallel. Alright? So we're just flipping the language on you, and again, the procedures in solving the problems are actually very, very, very similar. The difference is in the directions. So yesterday, again, we said m is parallel to n, find the value of x. But now we're saying find the value of x so that m is parallel to n. So we want to go in search of a value for x that would create parallel lines, that would make these lines parallel. Now looking at these, locate your transversal as always. So there's my transversal. Here's my sandwich lines. Alright, so my angles I'm focused on are on the inside. So we're looking at interior, and they're on the same side of my transversal. So interior, same side, we know same side is supplementary. So we know 3x minus 8 plus 5x plus 4 is equal to 180. So we have same side supplementary, so now we can go ahead and solve this equation. So I have 8x minus 4 is equal to 180, and then we're going to add 4 to both sides. So I get 8x equals 184, and then I divide by 8, so x equals 23. Now what we've done is we found a value for x that would create parallel lines, because if we put 23 in, if we go 3 times 23 minus 8, we get a value of 61 degrees. And if I have 5 times 23 plus 4, I get a value of 119. 61 and 119 are supplementary, so therefore my answer checks out and x is 23 is correct. It does create a relationship that would make these lines parallel. So again, it's just a way of thinking. The language is different. Other than that, it's pretty much the same. Alright, now let's try to get a little trickier on you. So we have this diagram. So it says if angle 1 is congruent to angle 2 and angle 3 is congruent to angle 4, which lines are parallel? Now, the tricky part about this is we got a lot of stuff going on here. We got a lot of lines. So let's focus on this first part. If angle 1 is congruent to angle 2, we need to identify which lines are parallel. So first thing you need to do is identify your angles. Here's 1 and here's 2. Now, before we can decide parallel lines, we have to decide which line is our transversal, because there's a lot of lines here. So we want to focus on what line do they share. Well, they share this line right here. Alright, so now based on this transversal, what is the relationship of my lines? Well, they are alternate interior angles. So that's my transversal. So the resulting parallel lines would be here and here. Alright, so angle 1 is congruent to angle 2. So we could say MN is parallel to QP. Now you could also call this line MO, NO, anything that would explain that line. Now, so we know MN is parallel to QP. My reasoning is because alternate interior angles are congruent. Alternate interior angles are congruent. So that's my explanation. Now be careful. If this was on a test, it would be a little more formal, and it would probably say write in complete sentences. But here it just asks us to name which lines are parallel. We did that. MN is parallel to QP, and our explanation is the relationship that exists. Alright, so now let's look at angle 3 and 4, because this is going to change things a little. So now we're focused on angle 3 and angle 4. So we're down here now. If it helps sometimes, turn your paper around. So like you could flip your paper around this way, and then you're used to seeing it in that way. But if not, I can't turn my screen and you guys see it, so we're going to leave it as is. So we're focused on the two angles that are named. Now identify the line they share. Well, this is the line they share, so that's the transversal. Now let's see what type of relationship. Well, they're same side, but they're not interior exterior. One's interior, one's exterior, but if you look a little closer, you can tell that they are corresponding. Out of these 4 pairs, it's on the bottom right, these 4 on the bottom right. Alright, so when we look at this now, this is my transversal, so my parallel lines that exist are right here. Alright, so here my solution would be when angle 4 is congruent to angle 3, we have line QM parallel to line NP, and my reasoning is corresponding angles are congruent. So basically what you're doing is looking for one of those reasons up above. We had 5 reasons up above. If corresponding angles are congruent, then my lines are parallel. So we could use that whole if-then sentence here. If corresponding angles are congruent, then my lines are parallel. And which lines are parallel? Well, OM is parallel to MP. Alright, so that's all I got. Have a good one.